It's great to be here, and even virtually to be back at UWE and see familiar faces and to meet some new people as well. This paper is about a collaboration between Birmingham School of Architecture and Design and Co.LAB Dudley. So it was part of a module called Co.LAB, Collaborative Laboratory, which is a module which brings together second-year undergraduate students across a range of design disciplines with first-year postgraduate students to engage in live projects with real clients, artists, organisations, residents associations, community groups in the region of Birmingham and the West Midlands. This particular project was set up with Co.LAB Dudley. Co.LAB Dudley is a social innovation lab, which is a hub or a platform which brings together people with different skills and knowledges and supports them to test a range of different ideas and interventions and to prototype ideas using a range of different tools, tactics, strategies, and ways of learning. The project was really set up to respond to how the high street might change after the pandemic. And we were very interested in thinking about the future for the high street, how it might change and evolve, and how we could move toward thinking how it could be regenerative in its design. This is a very brief overview that one of the students prepared of the many layered creative process which our students went through over this 10-week period. So it combined desktop research, exploration of critical urbanism texts, creative deep mapping, the creation of a gift from the students to the high street, creating connections and conversations with Co.LAB Dudley's network called the Time Rebels via a digital human library. We use tools to help navigate how we project into the future and bring back stories from the future. For example, Rob Shorter's Imagination Sundial, and Co.LAB Dudley's Guiding Principles, as well as a range of other tools such as collage, storytelling, poetry, and much more. There was this really strong collaboration between the student group, us as academics, and Co.LAB Dudley and their extended network throughout, with a lot of points of connection and points of reinforcement of the project. So the student group ended up creating 4 stories of the future that they brought back to the present. And these had a range of different focuses, all of them looking at systemic issues. I'm not going to talk about any of these projects in detail, but rather the focus of what I want to talk about is how we can move from education for sustainable development into regenerative design. These principles here from Tilbury and Muller are really useful in thinking about how we ran the project and reflected on it. And I'm going to go through each of these in turn. These are future thinking, critical creative thinking, participation and participatory learning, partnerships, and systemic thinking, to think about how those principles were brought out in the project. So starting with future thinking, we were engaging students in imagining preferred visions for the future and engaging them in exploring their assumptions and building ownership and responsibility for what a regenerative future might be like. This was underpinned by reference to writing of Rob Hopkins in From What Is to What If, and also the ideas of being a good ancestor. Here, narrative was really important in terms of allowing students to reflect on these stories of the future. And we framed tasks to make them positive, such as tasks to remember when or how might we, questions which gave a narrative framing to students who were then asked to imagine the future and looking back on how we got to that future. This brought in issues of the pandemic, spatial injustice, and the climate challenge. Second theme, critical and creative thinking. This is a very interdisciplinary project and explored alternative ways of thinking, acting, and making to imagine alternatives to business as usual approaches. It really strongly tried to link learning and doing, creating space for rapidly testing ideas, including reflecting on how people interrelate, understanding cultural differences, and creating alternative ways of living together. Students were engaged in active reflective and learning in an open process And this was a process which students found actually really uncomfortable and required the team together to make safe spaces where students could allow themselves to feel vulnerable and at risk. This openness was designed into the module and enables a deeper connection and empathy between the students, the collaborators, the high street, and the more than human. One of the key things we had to do was build confidence and celebrate the moments where this all came together to reinforce the work that students were doing and help them to shift from delivering against a defined project brief to an open process, walking in different shoes. The process of participation itself was really important in building ownership of the project and a sense of empowerment, moving towards activism. It was a collaborative process. Students were collaborating, not in competition. We were asking them to value different perspectives and knowledge systems, and also to listen and co-design with multiple connections. Live projects such as Co.LAB are one of the few opportunities students have to interact and collaborate with others whose perspectives and experiences might be very radically different from their own. Digital tools enabled cooperative sharing between students and the collaborators. It was a genuine exchange of ideas. But of course, being online, it was difficult to make very personal connections, which would have perhaps reinforced that process. The stage of the project called The Gift was really important and was a key point where students presented something as a gift to the high street, and Co.LAB Dudley gave feedback and celebrated those as a point to bond people together and really become a launching point for the future visions. So partnerships, these are a motivating force towards change. They empower people and groups to take action and build capacity. Nurturing trust between the team who are running the project, the teaching team and Co.LAB Dudley, came from shared values and long-term relationships between some of the participants. There was a sense of generosity in this, of sharing resources, sharing ideas, and it being a two-way collaborative process. There's also a sense of generosity in sharing partners and networks and making links beyond the project. For example, the Time Rebel Network acting as a human library. And we are also building an ongoing legacy in collaboration with others in the school and other organizations nationally as well. Finally, systemic thinking. We encourage students to go beyond problem solving and cause and effect, to really think about the systems that affect the high street, this complex ecosystem. And understanding and embracing this was a real challenge and something we really encourage students to engage with through mapping, the gift, and these multi-layered future visions. But it was important that it was place-based, that it focused on both human and non-human, brought in multiple perspectives, and explored systemic challenges such as food industry, technology, and biodiversity. Just to end with, and thinking about how we create the conditions for radicality, the module, the project and the pact created the conditions for shared learning and emergence of students' insights and creative and collaborative experiences. We see this approach as being very, very distinctive to teaching young designers, where one is, it's kind of suggestive of a hierarchy of knowledge and a traditional learner-teacher relationship. What we're trying to do here is to create a more collaborative process, the space for participants to learn through independent and collective reflection, imagining, paying attention to the experience of others, valuing those experiences, engaging with the richness of creative process, and being in a more meaningful relationship with their teammates, tutors, and the Co.LAB. We think this needs a shift in thinking. Going forward, we might create an intention to nurture the conditions for these individual, collective, more than human practices and thinking, leading to the design of regenerative futures. This requires a radical shift in how we educate future practitioners. And finally, the pact is part of a wider systemic issue around how we shift the site of knowledge-making power from the exclusivity of the university institution, engaging with students, local groups, and championing the idea of university as agent of change in the city and educating activist practitioners. Thank you.
I'm architect, and I'm a university teacher in an architecture program. I would like to thank for this opportunity of sharing my concerns with so interesting people. So architects as activists on the path of sustainability seems to be more than important. I would even say that is crucial. The main purpose of this presentation is to underline the importance of education, more concretely what concerns the future architects as responsible for making of the architecture the protagonist of an activist role in the sustainability transformation. Alain de Botton, a French philosopher, wrote in one of his books that space determines in a significant way the form by which we are able to believe, not to behave. In other words, space influences the way we feel, the way we want to feel, and the way we behave. So I believe in the fact that if our houses, our cities, our environments are taught and designed based in the principles and concerns for sustainability, they may influence and educate us. Of course, this is far from being enough. Since the moment we get up, the process of waste begins. It's the water running for a bed of a shower, the meals, the garbage, all the garbage, the cars. Well, the list would be endless. But worse than this is the fact that we are so used to these routines, we didn't even think of it, which needs and implies a long way of awareness to change it. That's why education is primordial, more precisely what concerns architecture teaching, architecture learning, and architecture searching. What happens most of the time in that research in practice lacks what is perhaps its most important goal: people and environment. The cult of the elites of the star system led to a blindness, diverting attention from what really matters. It's urgent to review the civic and social responsibility architects must have. A change in conscience and in behavior implies almost a radical change in the architectural programs, in the contents of the curricular units, and mainly in the way we teach and how students learn. If learning by doing has been for a long time pedagogically a path to learning, learning by thinking seems now to be a first step to research towards the objective of learning by researching, turning doing in a conclusion based on real, conscient premises, responsible searches, and reasoned theories, where architecture appears as a result of an interdisciplinary, integrated, and conscient research. Even when researching, an approach to sustainability is in most cases done in a fashion basis. So it's urgent to reduce, it's urgent to re-educate ourselves, teachers, students. So architects can do architecture than can educate people, even if for it, it's necessary to break rules, to review old principles, and to rewind our process of thinking and designing.
My name is Christina Nan. I'm assistant professor at the University of and I'm going to talk today about sustainability and global entangled complexities, re-examining profession. So first of all, I'm going to be talking a tiny bit about today's context in which we live, right? So it is a rapidly changing context, which is very much dictated by hyper-consumerism, hyper-digitalization, and mass customization, right, as aspects of the everyday. And I'm going to look about these at these as how they manifest on an urban level, on the level of the building, and also the level, to point out and carve out different forms of this global entangledness and what it means in terms of the challenges ahead, and also tackling sustainability and misconceptions about that. Okay, so the first framework which I'm looking at, right here, I'm using a quote from Michael Beck from Inventing Future Cities, right, where he's talking about a series of digital transitions that we're currently witnessing also in the future, and how some or all of them might relate to digital aspects, such as, for instance, the fourth industrial revolution, right? And this is connected to artificial intelligence, trends and development in biomedicine, nanotechnology, and communications, right? And what happens is, and why it's relevant to architects and to the material footprint that relates to this, the convergence of computers and communications, and their embedding into the social, but also into the built environment. Just overall, I assume that our viewers know what Industry 4.0 is. Just very quickly brushing over it, right? So we had 4 industrial revolutions, starting from mechanization to the mass production, computer and automation, and nowadays, right, cyber physical systems, which rely basically on network communication, the transmission, the seamless transmission of data from one device to another, cutting out, for instance, when it comes to Factory 4.0, the middleman. And another framework point of view from which I'm going to address the subject matter is, right, the functioning and derelict backstage machinery of globalized urban life, right? So all of the mechanisms and also the resources that sustain our activities and processes as such. Right, and what does it mean? So how does the global then come together with the local, right, in different frameworks or in different contexts? And there we have to distinguish between chains of correlation and chains of causality. And this is also very important when it comes to sustainability, and to really understand the local but also global impact that actions have, or also education, or when we are pushing for certain types of phenomena like the smart city, like the use of, for instance, AI, like machine learning, like censoring the city, right? And this entangledness and where the complexity is coming from, this correlation between the economy, consumerism, digitization, infrastructure, and the territorial and urban transformations that come from it, right? Which go hand in hand with also cultural developments. And I'm going to exemplify some of this global entangledness and the ramifications on territory, landscape, and the built environment. Right. As architects, right, so also in education, we talk a lot about the visible materials such as, timber, brick, concrete, right, the obvious set of materials when it comes to construction, when it comes to architecture. But what about the invisible materials that relate, for instance, to trends such as, right, put everywhere sensors and develop a smart city? What if the facade, right, reacts to interactive architecture and so on, which guarantee processes, but also the seamless functioning of infrastructure. Here we have, for instance, an example, the electric city of Europe and the implementation, the push towards electric cars, right? And the urban implications that come then from implementing the electric cars, and then also the next step, right? The driverless car, for instance. But if we look very closely at the car and what the driverless car, the electric car have in common, they all rely heavily on lithium batteries. Here we see a lithium battery from Renault, right? And since there is this industrial and global push towards electric cars, the lithium demand has increased by 20% year on year. And with a projected rise in electric cars, lithium is predicted by some to exceed supply by 2023, so in 2 years' time, right? Very, very close to the present. And if we look at, so from the smart city to the electric car, driverless cars, right? The urbanism around the driverless car, right? Brings us back when we're looking at this material footprints and territorial implications to very specifically lithium and other components that are key to this type of batteries. At this, just side note, at this point, we don't really recycle the lithium, right? It is far cheaper extracting it. So for instance, the battery of a car contains 8 to 10 kilograms of lithium, 35 kilograms of nickel, 20 kilograms of manganese, and 14 kilograms of cobalt. Needless to say that the extraction of these minerals is very, very problematic, right? On different continents, also the type of labor that is employed, for instance, Congo, quite often problematic due to child labor. And these are then the territorial implications and the landscape that this type of mining leaves behind. To that note, when you're looking in very particular at lithium, one can wash it out from the sand, right? What is happening here with brines, or you can have again proper lithium mines, right? And these are this seductive, right? Images, really colorful, really nice that we see of lithium, but it brings, I'm just looking at the time, right? But it comes with all of this negative implication when it comes to ecology, when it comes to sustainability on the level of the hyper local. The Atacama Desert, it is a desert, right? So there is a lack of water. They use the water from the underground to wash out, right? The lithium, and then the water is left to evaporate, which is very, very problematic for the local ecologies, ecosystems, but also for the communities that do live in or around, so native communities that do live in and around these areas, right, of extraction. When it comes very particular to smartness, sensoring, AI, and computation, what is the common denominator of all of these? They only work, right, if we have fiber cable networks that guarantee the functioning of the internet, just the same as with cyber physical making and Industry 4.0. And no, we depend in terms of the building scale on the building typology of the data center. Here we can see a data center campus. There's a mistake in spelling, right, in Santa Clara. This is what data centers look like. They are this very, very big black boxes, right, not built for humans, but really built to accommodate machines and the seamless and needless functioning of the machine itself, right? The less access humans have to a data center, the better and the smoother in terms of the processes that need to run. There. Now, this is, for instance, a data center by Google in Groningen in the Netherlands. Right there, we can see the territorial scale of such infrastructure. You don't only find them at remote sites outside of the urban, but more and more within the peri-urban and the urban itself. So for instance, London and the highway belt around it, right? The inner city highway belt has the highest concentration of data centers in the world, right? So what the typology and of the data center from the remote sites to the city where they occupy this very, very large footprints, they're normally not visible to the human eye. You can't really tell within the density, oh, this is a data center, right? But, sorry, they do have considerable implications when it comes to, because of their, as mentioned, their vast territorial footprints, the large encapsulated spaces, the energy and the logistical relevance, which leads to an impact on the landscape. The neighboring urban, due to real estate prices, they push ridiculously the real estate prices ridiculously high up, because geography and geoposition matters a lot when it comes to data, to then local and global energy landscapes, right, as well as the urban climate because of the heat island effect, for instance. When we look closer at the global electricity, for instance, right, so it is estimated by 2030 that communication technologies and data centers may be responsible for 3 to 14% of global electricity usage, right, which is quite remarkable. So the more there is an encouragement, right, towards, for instance, smartness, towards the sensoring, right, all of that data, that big data, needs to be processed somewhere, right, and stored also. And this happens in data centers, which then leads then also to a rise in the electricity demand. The more everything becomes part of the digital network, the higher that the price of electricity is that we have to be willing to pay. Right, and for instance, not only electricity, right? So the problem with data centers is very much cooling, and there are, I mean, different estimates. But here, one very specific one from 2014, that 100 billion liters of water will use for cooling purposes in the US, right? All right. When it comes to the local electricity, the largest data centers, they can surpass 100 megawatts. What does that really mean, right? So if we're looking at, and this is all in relation to US households, right, which do have a higher energetic footprint than European households, right? So it equals roughly the energy of 80,000 US households, which in European households could mean, for instance, it depends very much on the country, 100,000 households, right? So very, in terms of the magnitude and implication, they're really at a large scale. And from the invisible materials to the data centers, the topology, to then the large-scale urban and territorial implications. When we look, for instance, at these advancements in digitization and technology, they lead, for instance, to the formation of new types of spatial clusters, such as Silicon Valley. We know that very well, Shenzhen, and the Pearl River Delta, right, which was transformed due to all of this developments in no time from a fishing village into the fugitive Silicon Valley of the East. Here we can see aerial view of the Pearl River Delta, past and present, and the urban developments that happened. If this is not exactly clear and convincing as an image as to what happened there, right? Here we can, this map might maybe communicate the scale of transformative impact, right? And its magnitude maybe a little bit better, right? And in the present, not to waste over, to wrap it up, right? So I guess that it is important in terms of to properly teach sustainability and to not class the moralist finger in terms of, right, oh, for instance, concrete is bad, timber is good, steel is bad, let's go for timber, right? We couldn't build all out of timber, right? Our woods would disappear from today to tomorrow. It is important to acknowledge and to embed in teaching these complexities of hyperconnectivity and consumerism, which reshaping our everyday from the way we live and work, right? To then consumer behavior communication and the built environment. And this is a quote from Adam Greenfield, right, who's coining the expression post-human everyday, where it is again about this large-scale data analysis, algorithmic management, and machine learning techniques, automation, and robotics, which are all embedded very clearly within reality. They do have material footprints that can be very clearly identified and drawn out, and that can be quantified, right, in terms of energy, material resources, waste, environmental impact. In terms of a direction forward, understanding this global entangledness, the causality and correlation, because there is a difference, right? When there is a chain of causality and things just correlate with one another, to set up a shared cross-disciplinary knowledge base, a methodological framework also as to how to address, right, these complexities and this entanglement, to translate it into architectural decision-making or design decision-making, being urban, being on the architectural level, and to identify very pragmatic, quantitative and qualitative tools of analysis for this global entanglement and its expression on the hyper-local level, to evaluate them and to simulate. And maybe like this, we will be able to better assign, evaluate, and implement sustainability, but also its social functionality, because at the end of the day, sustainability is nothing if it doesn't serve the purpose of social functionality and society as a whole. Thank you very much.